The space between stars is a frozen, silent desert, filled with ancient fragments of forgotten worlds. From time to time, one of those fragments breaks free from its home system and begins a solitary journey that can last for millions, even billions of years. The comet, known as 3I Atlas, is one of these wanderers. It wasn't born under the same sun that warms our planet. It comes from somewhere far beyond, perhaps from a star that no longer exists, and now after an eternity drifting through the cosmic dark. It crosses our solar system, offering scientists a rare opportunity to study something that truly comes from another world. The name 3I tells us that it is only the third interstellar object ever discovered. Before it came Oumuamua, the strange cigar-shaped rock spotted in 2017, and Borisov, a comet discovered 2 years later. But 3I Atlas is unique. It's the first interstellar visitor to be observed well before reaching its closest point to the Sun, the perihelion, giving astronomers time to track and analyze its behavior in detail, using some of the most advanced telescopes on Earth, such as the Nordic Optical Telescope at La Palma, Canary Islands. Astronomers captured high-resolution images of 3I Atlas between July and September of 2025. In July, the comet was about 4.6 astronomical units away from the Sun, over 4 times the distance between Earth and our star. Even at that great distance, it was already active. By September, at less than 2 astronomical units, its brightness had increased dramatically. That brightening wasn't just visual. It revealed that the comet was releasing more and more material as it approached the Sun. But what truly surprised scientists was what was driving this activity. In comets native to our solar system, sunlight heats the icy surface, causing water ice to sublimate and form a glowing tail. Yet in 3I Atlas, the main driver wasn't water at all, and it was carbon dioxide. CO2 can sublimate at far lower temperatures than water ice, which explains why the comet was already active, while still far from the Sun. This discovery changed how researchers understand the chemistry of interstellar bodies. If 3I Atlas is dominated by carbon dioxide, that means it likely formed in a much colder region than where our own comets were born, perhaps in the distant outskirts of another planetary system, where volatile compounds are abundant and sunlight is faint. In just a few months, its appearance evolved rapidly. At first, its tail, that stream of gas and dust stretching behind the nucleus, was pointing toward the Sun, forming an unusual anti-tail. This happens when particles move slowly, creating a faint veil in front of the comet instead of behind it. But as it came closer to the Sun, solar radiation pressure pushed the particles away, transforming the tail into the classic form we're used to seeing, a bright trail pointing outward from the star. This entire transition took about a month, during which the comet's activity nearly doubled. Early observations showed it was ejecting about 180 kilograms of dust per second, and by September, that number had soared to over 400 kilograms per second. The dust grains themselves were relatively large, about 100 micrometers in diameter, moving at only about 5 meters per second. Big, slow particles like these tend to cluster and linger around the comet before being pushed into space, a process that shapes its unique tail structure. When scientists compared 3I Atlas to other comets, they noticed something remarkable. Despite its interstellar origin, it behaved almost normally. Its brightness, dust production, and even its morphological changes were consistent with many long-period comets from the Oort cloud, the vast icy shell surrounding our solar system. This suggests that interstellar comets aren't necessarily exotic or unpredictable. Some may follow the same basic physical principles as our own, but there were still important differences. Compared to Borisov, 3I Atlas was far more active. It contained larger amounts of volatile material, especially CO2, which made it brighter and more dynamic. That contrast implies that interstellar comets can be as diverse among themselves as solar system comets are among each other. There isn't one type of interstellar comet. Each is a unique messenger, carrying the signature of the place where it formed. The dominance of carbon dioxide also explains why 3I Atlas remained active even in the cold, distant regions beyond Mars. CO2 can sustain cometary activity at distances where water ice would remain completely frozen. This means some comets born around other stars could stay alive much longer as they travel through the galaxy. 3I Atlas moves at breathtaking speed, roughly 58 kilometers per second. That's so fast that the sun's gravity can't trap it. It came from the depths of space and will eventually return there, leaving our solar system behind forever. After swinging past the sun, it will continue its eternal voyage through the interstellar void, perhaps one day appearing in the skies of another world, where alien astronomers might wonder where it came from. For researchers, this comet is a priceless opportunity. For the first time, we can study an interstellar object, both before and after perihelion. That means we can directly compare how sunlight alters its composition, brightness, and surface structure. As it moves away again, new observations may show whether it loses mass, breaks apart, or remains intact after its close encounter with the sun. Soon, it will also pass relatively near Jupiter, drawing the attention of multiple space missions. Probes like Juno, TESS, and Europa Clipper are expected to collect valuable data from different perspectives, turning this into one of the most thoroughly monitored cosmic events of the decade. Never before has an interstellar object been tracked so closely by so many instruments. Every new piece of data confirms the same thing. 3I Atlas is the most studied interstellar comet in history. It carries within it clues about how planetary systems form around other stars, and possibly how organic molecules, the raw ingredients of life, spread between them. If comets once brought the first building blocks of life to Earth, then each interstellar visitor is a time capsule drifting through eternity, holding fragments of creation from distant suns. When we look up at the night sky and see a faint light streaking across the darkness, it's easy to forget what it represents. That glow is not just ice and dust. It's a traveler from another star system, older than humanity itself. 3I Atlas reminds us that the universe is alive with motion, and that every fragment of rock, every shimmering tail of light, carries a story written billions of years ago. As it slowly fades back into the cosmic night, taking with it the sunlight it borrowed, we're left with something even more valuable: knowledge. The awareness that the universe still holds countless wanderers like this one, crossing the space between stars, waiting to be discovered. And each of them, in their silent journey, has the power to change the way we see the cosmos and our place within it.